All right. I welcome everybody to this Zoom meeting, and my name is Tianyan Chen. As again, I'm the interim chair, of the department. Again, thanks to everyone, for taking time to join us. Okay. I also want to give thanks to the admission office so that we have this opportunity, to tell you about department program. Okay. And then within this 55 minutes session, I'm going to use about 15 minutes, to run this slides. Okay, so you can get an idea, about our department. Okay. After that, we're going to open up this session so that we can entertain some questions you might have. So mechanical engineering is a branch of engineering that combines engineering physics and mathematics with material science to design, analyze, manufacture, and operating mechanical systems that are needed in almost all industrial sectors, okay, such as manufacturing, power generation, aerospace, renewable energies, biomechanical systems. You can name it. Okay. And the purpose of mechanical engineering program at Gonzaga is to produce quality mechanical graduates and prepare them, okay, through continued learning, okay, to have a successful career in whatever they choose, okay, as their career. So this slide, okay, gives you a rough idea of the courses you expect to take during your full-year study at Gonzaga. Okay. So at first year, you start off, by taking some fundamental, courses like mathematics, physics, chemistry. Then you move on to take more engineering courses, right, during the second and the third years. Okay. And during the last year, your senior year, okay, in addition to more advanced engineering courses, okay, so you also do a one-year senior design project. So first year experience, okay, and the curriculum, okay. So for freshmen, university has a first year experience program to help students to have a smooth transition to college life and quickly, adapt to the new environment. And for engineering, okay. Wait a second, I kind of moved too much. Okay. So within engineering, we also have this first year seminar, for the pretty much the same purpose, okay. And this first year seminar program, okay, it's a one-year program, running for 2 semesters. Okay. So we started this, first year seminar a couple years ago to match the university's new core curriculum. And one goal of this program is to provide the engineering experience to freshmen and help them, to select an engineering program if they are undecided. Another goal, of course, is to aid in retention. Also, this first year, seminar program is a platform for students to develop skills, such as communication, design, and programming that can be vertically integrated, through the engineering programs. So in terms of student opportunities, we are proud of, this rich extracurriculum activities we have on campus, which includes, the internships they can do. Okay, they can perform research with professors. Okay, and they also can choose to do study abroad program. Okay, also we have a number of student clubs. They can participate. Pick and choose. Based on their interest. Okay, and many of these clubs. They do projects and eventually they take that to the national competition. senior design project is a very important part of a program, okay, where students' learning is culminated in this 1-year design project. And most of these projects are sponsored by industry companies, which comes from real world engineering programs. So most students are really excited, about this senior design project because they're working to solve real world engineering problems. So besides, we have these teaching labs, okay, so that are integrated, through our 4-year program. Okay, we also have, a number of research, research labs, okay, dedicated by different professors to do, research. Okay. And then many of these, research labs, having students, working in the lab. Okay, so that's a great opportunity for them to, to study more and learn more and get hands-on experience. Besides teaching labs and integrated in the courses, okay, and the research, students can do, with different professors, okay, and we also have, machine shop, okay, we have, manufacturing technology center, so students to work on, their different projects. Okay. So the hands-on experience is really emphasized, in my, program. Okay. So besides they're working, in the machine shop, okay. So at the times we have, desktop teaching modules, okay, in the classroom settings to enhance, their learning. We also have the students, design and build prototypes, from scratch and to finish, where students really have a sense of accomplishment, at the end. So this will enhance their confidence, okay, when it comes to the point, they need to, look for, a job, for their career. So we all knew at this point, Gonzaga, is a Jesuit, school. Okay. What it means to us, okay? I guess for different people, it might mean slightly different, okay? For me personally, okay, it really means, we need to be a good person, okay, before we become a good engineer. Okay? As far as our program goes, okay, it means we care for our students, okay, and through their study of mechanical engineering, okay, we educate them, okay, to be their best, okay, both for themselves, also for the society at large. So as far as the career goes, okay, most of our students, okay, go straight to industry, okay, or engineering firms, okay. Some students, go to graduate school, okay, to get a more advanced study. Okay. We also have students, working in the government agencies. Okay. So what you see here is some pictures, we have the students, attended, career fairs. So from the faculty standpoint, mechanical engineering department, we have 9 full-time faculty. Okay. We have several other slides, so we're going to go around, okay, to have, we're going to use this, opportunity so that we can get some highlights of what we do, okay. Then we're going to open up, this session for questions that you might have, okay. So to start off, Mark, can you take it from here?
Great, yeah, thanks, Talion. So I'm Mark Baumgartner. This is my 5th year here, just finishing up my 5th year here at Gonzaga. So I did my undergraduate degree at Georgia Tech, and then was in industry for a while, working for a company called UOP. They were an oil technology company. And after that, I decided I wanted to get more involved in biofuels research and went back to graduate school, where I went to Colorado State University. And in particular, was in their combustion and kind of engines research group. And a lot of that research is kind of carried over to my time here. Talion, you can go to the next slide. So I teach thermal fluids courses, so Thermo 1 and 2, fluid mechanics, heat transfer. So those are all junior level mechanical engineering courses. And then I also teach a senior level technical elective in combustion. And a big piece of that class is really getting hands-on experience. We disassemble an engine, take a bunch of measurements, build a mathematical model of it, predict the performance, and then put the engine all back together and actually do some engine testing to kind of compare our model. And so, Talian, you can go to the next slide. And then in my lab, I do a number of different research activities and try and involve students in as many of those as possible. A lot of my research is focused on fundamental combustion, really looking at how can we make things burn cleaner. And in particular, I do research on so natural gas, syngas blends, biogas blends, and then also some renewable liquid fuels as well. And then do a little bit on developing biomass cook stoves for the developing world. And just kind of in all of those areas trying to work to lower emissions. And then, like I said, there's a number of different research opportunities in my lab, and students can get involved in those from day one if they like. So that's kind of me in a nutshell. I'm happy to answer any questions, and so I'll pass it on to Dr. Chen.
Okay. So for me, I'm a professor of mechanical engineering, and my main area of expertise is heat transfer, or in general of thermal sciences. Okay. So I had many years of experience in both academia and industrial settings, okay, where I did a research, I did a product design. So I also had a multiple disciplines background. What I mean is I have, mechanical, I also have electrical background, which really helped me, design interdisciplinary settings, systems involving, mechanical, electrical, knowledge. So the courses I taught at Gonzaga are including, thermal sciences courses, okay, heat transfer, fluid mechanics, and thermal sciences. Okay, a couple of years ago, I also developed advanced energy systems, okay, as a tech elective, which emphasizes, okay, a study of renewable energies, okay, including solar energy, okay, wind power, and so on and so forth. So I also teach measurements course, okay, where we're going to learn how to design systems and instrumentation to measure different mechanical variables. And my research interest, okay, is pretty much, focused on heat transfer and applications, in different kind of systems, okay, such as electronics cooling and thermal management, okay, and heat transfer enhancement, okay, in different energy and HVAC systems, so that we can, use our energy in a more efficient way. So then we have. Next is Professor Capobianchi.
Yes, good afternoon. So my name is Dr. Capobianchi. I'm a professor and chair of mechanical engineering. Been here, this is my 24th year at Gonzaga University. My main area of expertise is fluid mechanics and heat transfer. I have about 10 years of professional practice in industry in the military electronics industry for aerospace applications, and more than 20 years as faculty in academia. Like Dr. Chen and Professor Baumgartner, I'm also a thermal scientist, and so I teach the same type of group of courses: heat transfer, fluid mechanics and thermodynamics, and also measurements and instrumentation. My areas of research are in the heat transfer, fluid mechanics, and non-Newtonian fluids. So these are, you've probably seen videos and so forth of these fluids that kind of behave strangely. For example, there's a fairly famous video on YouTube of people walking across a pool of fluid, which is a viscoelastic fluid. Well, that's kind of the area of work where I'm working. I'm solving fluid mechanics and heat transfer problems with those fluids. I've also done work in the area of electrothermal co-simulation and in the measurements of transport properties.
Hello, my name's James Weston. I am instructor of mechanical engineering here at Gonzaga University. I graduated from Gonzaga with my bachelor's degree, and I've continued, got my master's degree at University of Michigan, Ann Arbor. I'm professionally licensed as an engineer. I've been at Gonzaga. I've completed my 4th year now. I've got over 35 years of industrial experience, primarily in the automotive engineering field, safety, emissions, fuel economy, and so forth at General Motors. Also, I worked for over 4 years in the Federal Republic of Germany. I'm fluent in the German language, and I teach the courses of Introduction to Mechanical Design, Engineering Economics, Dynamics, and a new course which was just added this year as an elective, Vehicle Dynamics. I'm also the mechanical engineering representative to the Senior Design Activity. Next slide, please. So I included a couple of things from our MENG 291 Intro to Mechanical Design Lab. I've actually got that piston here in my hand. This came out of an 80 horsepower Perkins diesel engine in an agricultural application. And Dr. Baumgartner explained some of the things that he works on with respect to combustion. I'm more focused on the area of the actual mechanical design using SolidWorks and that sort of thing. That piston that you see on the right in blue is a rendering from the SolidWorks 3D model, and we create these models as part of that course. And the 2-dimensional print to the left of that would be this type of print that you would learn to develop in the 291 and 291 lab course to represent that as a mechanical drawing from which a machine shop could build that part. So one of my primary focuses for my engineering students is to leverage my industrial experience and try to show them how their engineering coursework is applied in the real world, and to bring these sort of real world items into the classroom. I hope to see you all here. That's all I've got, Talian.
Thank you. Dr. Farrow. You need to unmute.
Hi, everybody. My name is Pat Farrow, and I've worked in the casting industry and also in the silicon industry, and then later in the alternative energy industry. And I was able to go to graduate school either during or in between some of those experiences. And my jobs were always in the realm of materials engineering. And I had a lot of fun doing it. I got to go all over the world and do lots of different things. And I've been teaching classes at Gonzaga for 11 years now. The courses that I teach are all the ones that either have the word materials or manufacturing in the title. And I love teaching all of them, and have recently started teaching one called biomaterials. So I hope you consider taking that one when you get here. And research that I do is related to hydrogen, and that was things I learned about late in my career when I worked for a company that was trying to build hydrogen-powered cars. And the two kinds of hydrogen topics to work on are things like, how do you creatively store hydrogen? It is a materials challenge. And the other half of it is studying the bad effects that hydrogen has on a lot of different materials. It's the study of hydrogen embrittlement. So I hope you come here. And if you want to do that kind of research, we'd be just glad to have you. So that's all I've got to say. Thanks a lot.
Dr. Kai.
Hello, everyone. So my name is Dr. Herman Craig. I am originally from India, so I did my undergraduate in this town called Chandigarh, which is in North India. Then I came to the United States for my PhD for grad school. So I did that at the University of Delaware. My research there was really focused in the tribology of solid lubricants. And I'll talk a little bit more about that in just a second. After finishing up my PhD, I spent 4 years at the University of Pennsylvania as a postdoc and then a staff researcher. And so I'm an assistant professor here, as I mentioned. I'm finishing up my second year at Gonzaga. I teach courses in materials and manufacturing, so sort of taking over some of the work that, some of the courses that Dr. Farrow has been teaching over the years. And so maybe, Tallene, if you could go to the next slide. So in terms of those actual courses, I've taught MENG 221, which is the materials engineering sophomore level course, sort of an introduction to material science for ME majors and some of the other engineering management students as well. And I also teach a junior level manufacturing processes course, which has a lab component. I'm actually sitting in the manufacturing processes lab right now, so I'm happy to sort of walk you guys through this later if you'd like. And then as of this year, this past spring was the first time I taught a senior level tech elective in tribology and surface science. So that is sort of derived from the research that I do and have done. And so this was offered for the first time in the spring. And in addition to those 3 courses, sort of spanning from sophomore all the way to senior year, I also supervise capstone senior design courses, or the senior design course. As far as research goes, I have the Tribology research lab here, which is right next door, right across the hall from Dr. Farrow's lab. And so tribology is probably a word that you haven't heard of before, but tribology is essentially the study of surfaces and relative motion. So a lot of it is material science. So one of the things that we're doing is developing novel materials, mostly polymer nanocomposites, maybe some thin surface coatings, with the goal of essentially reducing friction, reducing wear. So any components that have sliding motion, rolling, sliding contact, there's going to be eventual wear of those surfaces, those materials. So looking at both the material properties, the ways in which those stresses are sort of absorbed within those materials. And so here's a snapshot of the research lab. So the top image that spans the width of the slide is sort of a panorama of the lab right next door. On the bottom left, we have 2 atomic force microscopes. So we're doing both macro scale research, looking at sort of large material samples, but also doing research on the nanoscale mechanics and nanoscale tribology, stuff that you wouldn't be able to see with your sort of naked eye. So those are 2 of the instruments that we have in the lab. And then some custom built instrumentation that we have sort of, well, I should say the students have built for use in the lab. So these are custom built instruments. And on the right side of the slide are just 2 of the photos are from a poster session that 2 of my students presented at, and then just a fun photo of a lab get together. And so we're doing work pretty much at all length scales, nanoscale, microscale. One thing that I do want to emphasize is the lab is open for undergraduate students pretty much from day one, as Dr. Baumgartner said. I've had a freshman who started working with me in their first semester here at Gonzaga, and I've had students who've signed up for research in their junior, senior years. So as long as you're interested, you're welcome to stop on by and get started. So thanks.
Dr. Fitzgerald.
Thanks. I made sure to put the picture there just in case, the internet goes down, that sort of reasons. But my name is Dr. Fitzgerald. Came in the same time that Dr. Baumgartner did, so I'm just finishing up my 5th year here. My areas of interest are for stuff that moves primarily. Nonlinear dynamics is the overarching theme, control theory, so getting that stuff that moves to move the way you want it to, and how do we use computational methods to solve problems that otherwise would be intractable. I did my undergraduate back east in York College of Pennsylvania, where I was at the time, and then my grad career was at the University of Maryland in College Park, just outside of DC. Next slide. I'll be quick. So the classes I like to teach, get to teach, probably 6 of one, half dozen of another, are dynamics. That's to sophomores, typically. I've got to teach vibrations. So oscillating systems, what happens when you have large machines that have disturbances and you want to be able to not transmit those disturbances to other parts of a machine floor or working floor. System dynamics and controls, that's that weird donut shaped thing. It's one of the problems I really like in that class. It's the students know it as the dreaded bead on a hoop. And it's a really basic model of what's called a Watt governor. It was one of the earliest mechanical feedback devices to manage steam engines. And so we're worried both about its dynamics as well as how using feedback control we could design the performance of a machine to do what we want. And then some of the other courses I get to teach are a technical elective called Computational Dynamics. And that's the animation that's kind of scrolling by in the bottom. Hopefully it's coming through. So that is a 3-bar, just freely moving pendulum in a plane as an example problem of nonlinear dynamics, chaos, and how do we build equations that describe accurately from first principles all of those motions, and how do we go about selecting appropriate computational approximations and implementations to get a simulation, and what does that all mean? And so that's my stuff. Next slide, please. And in my lab, I'm mainly interested at present in experimental mechanics related to hawk moth flight. So in the picture on the bottom was a set of experiments that we had students working with where they grew some hawk moth wings. So these are large moth wings, large moths with large wings. And we diced them up and put them in a tensile tester, and we're measuring some bulk mechanical properties. This past year, I had a senior design project that was both a senior design and undergraduate research project that worked on expanding on some previous work that we had done. And those are pictures on the right-hand side. There is a containment box with some high-speed cameras that would watch one of these hawk moths or another insect fly around, and then the 3 cameras would capture in high speed videos of those moths flying around. And then the image on the bottom right is the sort of data that we collect in post-process to get what the information of the positions and the deformations of the wings are doing in time. Some of the stuff on the left-hand side, that's just some CFD and some fluid structure interaction stuff I've done, a little bit more on the theory side. And other stuff that I didn't have a direct picture for in the lab, like Dr. Kare had also said, I super invite anyone interested to start in the lab as soon as they can. This past year, I had a freshman step up and take over the robot chess problem. So we have a pair of robotic arms in the lab, and the current problem that they're set up to work on is getting them to play chess against one another. We also have some other like servomechanical controls apparatus in the lab, and a number of students have used those over the years in my senior elective class as hardware platforms to do their projects on. So if it moves, I typically am interested in it. That's my summary. All right, thanks.
Okay, I think we can open up the floor, for possible questions. Matthew, you can moderate that.
Yeah, feel free to start sending questions in the chat. I'll give them a minute or so, but I have questions too if none come in. Okay, nothing right now. Anyone can answer this if they want to, but how do you think this holistic Jesuit education is a benefit for our graduates from the engineering program when it comes to stepping into professional settings?
Well, part of it is the perspective that the students have in terms of the relationship of their profession to society as a whole, right? I mean, the whole idea of a Jesuit education is to marry those two aspects, right? There's the technical aspect of being an engineer, and then there's the reasons why we do what we do, right? And so everything should be driven by improving the conditions of the human condition, basically, on the planet, whether you're dealing with justice issues, or you're dealing with pollution issues, or what have you. That should be your driving and motivating force. There's an understanding of what we strive to do is to provide an understanding of why we do what we do, so that you do things with right motivations and so forth.
Awesome, thank you. We have a question. What tools should we get and bring for engineering? Just materials that students should be aware to bring to campus, and right. The laptop requirements if you have those.
Yeah, there's a laptop requirement. I'm not sure that there's anything else required. I mean, there's things that are probably useful, but the principal thing is the laptop requirement.
Well, I'm going to post the link to that in our chat too, so students can see it. Here we go. I heard that the engineering course load is a little above average. Would a student athlete at Gonzaga be able to pursue a minor without being overwhelmed?
Okay, so there's a couple of different ways to pursue a minor. I'll give you the least attractive way first, okay? And not necessarily the way that I would recommend, but the least attractive way is to add an additional time to your curriculum. So you go to a 5-year program. We have a standard advising sheet for 5 years, and use the time that it provides in the kind of the holes in your schedule to put in your minor courses. That's the least attractive way. The 5th year is an expensive proposition. I mean, aside from the cost of tuition and room and board and so forth, it's a year's salary that you're earning because you graduated, that you're not earning rather, because you're graduating a year late. Second way of doing that is to sit down with your advisor. So each of you will have an advisor within your own department, starting from the 2nd year onward. In your 1st year, you have a common advisor. And you lay out a curriculum where you displace some courses into the summer, right? So there's a lot of the core courses are available in the summer, and they're available online. So you don't have to be at Spokane to take them. And you take those courses in the summer, and that provides room during your academic year to put in minor courses. And that's a more attractive way. Either way, you have to put in time and some resources to do that, but that's the more attractive way of doing it. As a student athlete, you wouldn't be carrying, so you're not overloading the semesters. Either way, you're going to be carrying 17 or 18 credits a semester. And we have had plenty of student athletes and some very talented student athletes come through a program and do it successfully. So that is possible to do along with a minor. But it does require planning. If you make that decision into your 3rd year, if you wait until your junior year to make that decision, you've used up 2 of the summers that you need. And so you kind of, the only option you have then is to prolong your stay. So there's multiple ways of doing that. But if you have that in mind, you need to kind of think about that early on.
I would also add a quick comment on that too. So it depends on what you want to get a minor in, right? Some minors are going to be a lot more challenging than others, given the number of courses required for those minors. There's a few in particular that are pretty low add-ons, and most of these you can absolutely do, and people typically do within the context of their regular 4 years, and that would be a physics minor, which we've recently just kind of streamlined the options or the path to do that, where it's very minimal additional courses. Additionally, an applied math minor. And then there's also programs like the Hogan Entrepreneurship Program, which is a business minor as well. And all 3 of those options would be options that you could get within the context of your of a typical 4-year track here, and would not at least on their face require going and doing summer courses. So it kind of depends on what you want to get a minor in. There's definitely a lot of options where you can do that within the context of your 4 years without, going above and beyond kind of the 17, 18 credits a semester. And we have a pretty sizable number of student athletes that come through the program every year, as Dr. Capobianchi said. So
here, there's a question. Yeah, go ahead.
Oh, feel free to address it. If you have a question you want, go for it.
Actually, there is a question above that. Is a question about doing research projects, without much instructions. So I would say, if someone, come in and having interest in doing research with professors, they should get in touch with, these professors and schedule a face-to-face meeting and talk about those opportunities. And the sooner the better,
So I'll maybe, sorry, Talion, I'll maybe follow up to that. So I think the question, if I'm reading the same question, there was also a line about how you get involved as a freshman without much instruction. So I can only speak for myself, the freshman students that I've had come through the lab. I think of every research project as sort of a big chunk that you can dice up in whichever way you want. And so for students who are coming in first semester, college freshman year, yes, you will not have taken most of the classes that are required for junior level, upper level engineering. And so all that does is it just changes the kinds of things that you work on in the lab. And so really the part of the main project that a freshman would be given is geared toward what you would be able to achieve within whatever time you're committing to the lab. If a student comes in during their junior year, and the expectation is, all right, you've taken XYZ courses, you know those aspects of the research project that you can do, that you can work on something slightly different. So the part of the project that a student works on really is catered toward the knowledge that they have and what are the things that they really want to be learning.
Awesome. Next question that we had in order was, are you still planning on holding in-person classes this fall?
I think that's the plan for now.
We'll know more as the summer progresses, but that's the plan currently.
Yeah, I think just in the interest of getting to as many questions as possible, just to kind of touch on a few of these. So the core classes, the overall course curriculum is, the core classes are kind of baked into to the plan here. So those are distributed throughout the 4 years, and you'll take those as part of just a very typical path. There's a standard kind of path that every engineering student takes. One version of that path to kind of get to the next question is study abroad. Most engineering students will go do their study abroad in their spring semester of their sophomore year. That's not the only time that they can do it. That's just when most students do it. That option, especially if you go to Florence, but it's still true if you go to a few other places, you do just in the course of a regular curriculum. So it's a standard path that students take, and it's definitely doable and indeed typical that students do that with no time lost. Double major options would be pretty tough. I think what some students will do is do an extra year to do their MBA. I know I've had students do that in the past.
There's also
as far
some math double majors.
that,
They're not unheard of. There are also some math double majors.
some math double majors, yeah, and that's
they are
actually
rare.
gotten even more attractive recently with the applied math major. There's a lot of overlap there that you could do. The laptop question, I would refer you to. We can get those details out to everyone, right, Matthew? That's something that we continuously update every year, right, just to stay current. So I would just refer you to whatever
yeah, and for students that confirm, I believe that gets sent out in an email over the summer. So once that list is updated, you will receive an email about that, and that link will be live all summer too.
Great.
I want to put a plug in for our in-school IT staff, Patrick Nowacki, and the others that put that webpage and whatnot up and together. They're really open to questions should you have any really detailed stuff, and they're also the ones providing that support. So even as the summer goes on and you have more questions, they are the folks to talk to, Patrick Nowacki.
Yeah, I wanted to also add one more thing about the study abroad. The Florence program, so we have students that go all over the place. Auckland seems to be popular. Spain seems to be popular, but the Gonzaga and Florence program is actually our program. And we have a curriculum that's designed to graduate in 4 years that's integrated with the Gonzaga and Florence program. If you choose to go there, you would go in the second semester, that is the spring semester of your sophomore year. The courses that you would take there are the exact same courses you take at Gonzaga, same numbers. These are Gonzaga faculty. It's a Gonzaga administration, Gonzaga building. It's run by us, and so it's fully integrated. The other programs are run by other schools. For example, the one in Spain is St. Louis University. The one in Auckland is a state school there, and so they're those are different than the one in Florence. But the Florence one is completely integrated.
Next question that I saw in order was, are there recommended electives outside of engineering that benefit the student for their career?
Depends on what the career is.
Yeah.
Yeah. This kind of ties in with the minor as well. What I typically tell my advisees is you do a minor when you feel that you need a minor or you want a minor. So let me just give you an example. In the industries that I've worked in, which were military electronics and the aerospace applications, every project manager that I ever worked with was always a degreed engineer that had significant experience as a design engineer, and somewhere along the line got an MBA, a Master's in Business Administration, and then jumped into the management role, because engineering managers are different than business managers. Engineering managers have to be able to speak engineering to the engineers and business to the business people. So they're kind of in between both. Now, those folks, you know, when they went for their master's degree in business administration, had to have the prerequisite undergraduate courses. If that's where you're heading, and if the industry that you want to serve, in fact, works that way, then you should consider a minor in business, because that'll get rid of the prerequisite courses for you. That'll satisfy those. If you don't do that now, you're going to have to do that later, right? So there's a good reason to do a minor. If you don't have a good reason to do a minor, that is to say, if you don't have a particular need, some students, for example, will do a minor because they want to have that on their transcript. I had a student who was a dance major, and she wanted to have a minor in dance. It's a great reason to do a minor. But if you don't have a reason to do a minor, you don't do a minor simply because today's Tuesday, right? It's expensive, it takes time, it takes money, and so you pursue that when there's a need. Now, in the case of this particular question, you know, when you look at electives outside of engineering, again, it depends upon what you want to do. Going back to that earlier example, if your goal is to work in an area where you do some engineering management, if that's kind of the role that you're going to fall into, then yes, absolutely. And I would coax that within a minor. But or if, for example, if you wanted to do mechanical engineering within the biomedical field, you might find some courses in biology useful to you, or chemistry and so forth. In those cases, then I would do that. But otherwise, just for the sake of doing them, if you have an interest, great. Otherwise, I can promise you'll be busy enough without them.
Great. It is 5. We have 2 questions left. So for now, we won't take any more questions. On the page you accessed this Zoom link, there is Dr. Chen's contact information if you do want to reach out. It looks like we just had a response to the one about what manufacturing tools are available to students. If you do want to just quickly talk about the lab equipment that's available, I know that they are still doing construction on the ISE building that's scheduled to open fall 2021. So if you have info on just about what labs are available to students or types.
Harmon, real quick, you can just show.
Yeah. So here, let me flip the camera so you can not see my face, but instead look at the equipment. And so in the manufacturing teaching lab, we've got at least 3 3D printers right here that are used for the 301 lab, the manufacturing processes lab. And kind of walking through the lab here, over here we've got the metrology station. So we've got essentially a setup for surface polishing and optical metallography of metals. Back there on the far side below the window is where we have the composites. Just want to make sure I wasn't muted. Back there we have a composites fabrication station. So we're making carbon fiber beams, I-beams. Those are some of the things you're seeing propped up. Here we have a brake and press, some shears, sheet metal forming, a comparator. I know you mentioned a mill. So we've got one mill here, and then we've got a lathe, a manual lathe and manual mill right next to it. Some plastic injection molding, smaller injection molding machines are up here, those 2 right there. And then we have a metal injection molding machine. This is one of the newer purchases that we have in the lab. That's this whole thing right there. Back here then we have a welding hood for gas metal arc welding, and then a few furnaces that we use for forging, and then we have a propane fired forge as well, some simple drill press, bandsaw. And then back here very quickly we do have 2 Tensile testing machines. So the one that we normally use for the 301 lab is the one that's back here. So let me see if I can get closer. So we'll actually 3D print some dog bone samples for that class and do some simple tensile testing on this MTS. And then this big MTS, which is rated for a higher load, is typically used for testing those carbon fiber I-beams that I just showed you a second ago. But that's sort of the manufacturing lab in a nutshell.
And just to kind of note that the manufacturing lab is in addition to the Manufacturing Technology Center, which is basically our machine shop, which has some other things like full CNC machines, mills, lathes, all that sort of stuff. And we have a full-time shop manager, Bo Grillo, who can, from day one, students get safety trained, and he can get them trained up on kind of whatever piece of manufacturing equipment on that end, in addition to the course that both Professor Kare and Farrow teach as a part of their regular curriculum.
Right. Last question is kind of a good one to end on. Have you had much communication with your previous students or alumni with respect to their careers or what they're doing now? And how have they described their experiences as being a Gonzaga graduate from the engineering program?
So I would say on behalf of myself, so at the times I get the students, coming back, visiting us, or, reach out to me, with some questions they run into in their work, which, of course, I will be more than happy to help them, and chat about their situation, their good things are not as good things. Yes, just my experience, I have students either coming visit us, in person, or, reach out, through, email or chat on the phone, Yeah, that's kind of quite an experience I have, Of course, that gave me a kind of sense of accomplishment. Yeah, other people may have more, to say about that.
Well, Dr. Chen, I'll chime in here. We also have sometimes adjuncts who assist us with senior design projects as advisors who are Gonzaga alums. We also have some members of the Executive Engineering Council, which supports our dean, that are Gonzaga alums. And so the alums crop up from time to time also in the Design Advisory Board, which also supports the senior design activity. There's a number of Gonzaga alums in that activity. Myself, I'm the alum on this faculty list that you're talking about today. So I would say that there's good contact, but we could always improve that and look forward to some more.
Yeah, I would add, I have several alumni that keep in regular contact with me, and we chat about all sorts of things. I have one just this week here who's looking to change careers. He's in the power industry and wants to go a different direction and wanted some advice. I have students alumni who keep in touch simply on a social level. I hear from them when they go off to graduate school. We have a significant number of students that after they're in industry a while, then go off to graduate school, and you hear from them because they want letter of recommendations and so forth, as well as advice as to how to pursue graduate studies. So there's actually a significant percentage, and it's actually something that's very satisfying, at least on my end, to hear from them, and where this professional student to faculty relationship turns into a more social friendship relation. I would also add, one of our alumni went off to graduate school, University of Washington. He's now a PhD out of University of Washington. I'm doing research with him and collaborating. So we keep in touch in a number of different ways.
Yeah, I would also add to that I think for me, the most rewarding thing and time to see students is when they come back for the career fair to recruit other Zags, and that happens quite a bit. So yeah, it's kind of one of those self-fulfilling prophecies that's really nice to be a part of.
All right, well, that was the last question. Any sign-off comments from faculty before we let them loose for the rest of the night?
I don't have any.
Okay.
Actually, there's one question here I wanted to answer here. About pursuing possibly a minor in electrical engineering. There is no minor in electrical engineering. You can pursue specific courses that are useful to you, provided that you fulfill the prerequisite requirement. Those are the kinds of things you should discuss with your advisor once you're in the program.
So actually, speaking of that, I do want to say something based on my own experience. When I did my PhD degree in mechanical engineering, because of the nature of my work, I need to design electronic systems, for my PhD research use. So I took some electrical engineering courses. I ended up getting a master's degree of electrical engineering, which I benefited over the years different occasions. So I know electrical engineering, we don't have minor, but I believe we can do if someone chose to, they can do both majors, like a mechanical and electrical. I don't know. I know that it will takes a lot of work, but if one has a determination and they can do that, and they're going to benefit in the long run.
Alrighty. Well, on that note, everyone, thank you for attending. Have a great night. Confirmation deadline for Gonzaga is June 1st. Happy to hear that it was reassuring for someone in the crowd tonight. Like I mentioned, Dr. Chen's contact info is on the link where you signed up to enter this. I also posted a link to the mechanical engineering page where you can access more faculty contact info if you want to. But hopefully you all become Zags, and thanks for attending. Have a great night.
Hey, Matthew?
Yeah.
Matthew, could you add my name on that as well? So they
Yeah.
can contact me.
What's your email?
It's capobianchi@gonzaga.edu. Full last name at gonzaga.edu.
Got to make sure I spelled that right real quick. All right.
I spell it wrong all the time. It gets to him. It somehow always gets to him.
Yeah. You're not alone.
No problem.
Great. Thanks, everyone.
Yeah, no problem.
Thanks so
Super log
much.
off. Have a great night.
Have a good night.
Bye-bye.
All right, thank you.
Yep.
Yep.